Good morning, pre-calc. Today we are going to start our units on trigonometry. And this is a different kind of math than you've seen before. A lot of people get scared when they see the word trigonometry, but actually it's really not bad at all. Trigonometry means measurement of angles. It was used in the development of astronomy, navigation, and surveying. And since the development of calculus, the applications of trigonometry have expanded. Uh, it includes now sound waves, light rays, planetary orbits, vibrating strings, pendulums, and some orbits of atomic particles. Um, Trigonometry, I usually tell my students, is basically just a fraction, a rational number, with a measurement of one side of a triangle divided by another side of a triangle. Okay. So it's a ratio of side lengths in a triangle. So we're going to start off today's lesson about radian and degree measure and go through some initial things that you need to know before we really get into all the big trig stuff. First thing we need to do is to know how to draw an angle, how to label it, which way angles go, clockwise and counterclockwise, and what they mean. So here we have an angle that is not on a coordinate plane. And we have the vertex, of course, is where the two rays or the sides of the angles connect. And an angle has an initial side and a terminal side. The initial side is where the angle starts, and the terminal side is the end, or after the angle has, swung open, so to speak. You always need an arrow pointing that represents which way the angle is opening. So the initial side is where the angle starts, and the terminal side is where the angle ends. So if we put an angle on a coordinate plane, which we'll be doing a lot of that in trigonometry, the initial side is always on the positive x-axis. Okay, right there. That's always the initial side. And positive angles always go counterclockwise. Okay? So they're opening to the left. So a positive angle opens to the left. A negative angle opens toward the right. It's a clockwise rotation. So you got to remember that. Most we'll be dealing with is positive angles. However, you will run into negative angles once in a while. Right? So positive is counterclockwise, negative is clockwise. So what is a radian measure? Radians are one way to measure angles, and this measure is useful in calculus and, of course, pre-calculus. A radian is the measure of a central angle that intercepts an arc equal in length to the radius of the circle. So what does all that mean? Well, if I was to take this length right here of a radius and put it on the circle, laid it out on the edge of the circle, 1 radian would be equal to the length of the radius. So this distance of the radius and this distance of the arc are the same length. That is 1 radian. And in a full circle, there are a little over 6 radians in a full circle. 6.28 to be exact. Okay, that's going to come into play here soon. So 1 revolution around the circle of radius r corresponds to an angle of 2 pi radians, because 2 pi r is the circumference of the circle, and if you divide that by the radius, you're left with 2 pi radians. Well, remember, pi is about 3.14. Well, what's 2 pi? Well, it's 2 times 3.14, or 6.28. And that's about how many radians there are in a full circle. So if 1 revolution equals to 2 pi, what do the following equal? All right, if 1 revolution is 2 pi, what's half of a revolution? Well, it's half of 2 pi. Half of 2 pi is 1 pi. So halfway around the circle should equal 1 pi radian. A fourth of a revolution is a fourth of 2 pi, or half pi. So a fourth of the way around the circle, you should be at pi over 2 radians. 1/6 of a revolution, if we take 2 pi and divide by 6, we get 1/3 pi. And this is what it would look like if we were to draw the circle and label the major points on the axis. Here's pi over 2, that's a fourth of the way around. Here's half way around. Here is 3/4 of the way around, all the way back to the starting point, which is 2 pi. So 1 revolution is 2 pi. Since it's on a coordinate plane, remembering the quadrants of your coordinate plane, they start in the top right, quadrant 1, and go counterclockwise. Here's quadrant 2, quadrant 3, quadrant 4. So any angle in quadrant 1 is going to be between 0 and pi over 2 radians. In quadrant 2, they're going to be between pi over 2 and pi radians. Quadrant 3, they're going to be between pi and 3 pi over 2 radians. And then the last quadrant, quadrant 4, they'll be from 3 pi over 2 to 2 pi radians. This will come in handy in the next section when we talk about the unit circle. Another way to measure angles is in degrees, which you're probably the most familiar with. A measure of 1 degree is equal to a rotation of about 1 over 360 of a complete revolution about the circle. There's 360 degrees in a full circle. So 1 degree would be 1/360th. Since 2 pi radians corresponds to 1 complete revolution of 360 degrees, degrees and radians are related. And they're related by these two equations here. 360 degrees equals 2 pi radians. 180 degrees equals pi radians. Hence, 180 is half of 360. 1 pi is half of 2 pi. So here's our 2 rules when we're going to convert between radians and degrees. If you want to go from degrees to radians, you multiply the degrees by pi over 180. If you want to go from radians to degrees, you multiply radians by 180 over pi. Those are the 2 rules. Make sure you have those somewhere to use. Write them down. So let's convert the angles from radian to degree. So if I go from radian to degree, I'm going to multiply by 180 over pi. All right. So I've got pi over 2. And if I multiply by 180 over pi, what happens to the pi's? Well, they cancel each other out. Okay. And I'm left with 180 divided by 2, which equals what? 90. So pi over 2 is at 90 degrees. Pi over 2 is a fourth of the way around the circle. 90 degrees is 1/4 of 360. Okay. Next, 7 pi over 4. 7 pi over 4 times 180 over pi. I wrote 4, not pi. 180 over pi. The pi's cancel out. And if I multiply 7 times 180 divided by 4, what do I get? If you need a calculator, pull it up. 7 times 180 divided by 4. Seven times 180. Whoops. Enter, divided by 4. 315. So this is 315 degrees. Next, we have 11 pi over 6. We multiply that by 180 over pi. Again, the pi's cancel out. And we want 11 times 180 divided by 6. 11 times 180, enter, divided by 6. We get 330 degrees. Okay. Now, if you look at the next ones, they do not have pi in there. They're listed to you in radians. And we want to make them in degree mode. Okay. So 2.12 radians. 2.12 radians. How do we convert that? Well, we multiply by 180 over pi. 2.12 times 180 divided by pi. So let's do that on the calculator. 2.12 times 180, enter, divided by, let's use the pi button, which is right above the caret, second pi, enter. 121, we'll round it to 121.47. 121.47. And we continue to do the same thing for 7. 7 times 180 over pi. So 7 times 180, enter, divided by pi. 401.1, we'll call it. So how many radians are in a full circle? 6.28. So 7 goes a little bit past a full revolution around the circle. So it's going to be more than 360 degrees. All right. Last one. 11.23 times 180 divided by pi. So 11.23 times 180, enter, divided by pi, we get 643.4. So just remember, going from radians to degree, we multiply by 180 over pi. All right, now we're going to convert from degrees to radians. And we want to leave our answers in terms of pi. That means we want pi in our answer. So we're going to do the opposite, the other rule. We're going to multiply 315 times pi over 180. So if we do that, we get 315 pi over 180. But we can reduce 315 over 180. If we put that in the calculator, 315 divided by 180, and do math, enter, it'll reduce it for us. That's 7 over 4. But we want to leave pi in our answer, and we leave it up top. 7 pi over 4. Okay? Next one, 231 times pi over 180. We need to try and reduce 231 over 180. 231 divided by 180. Math, enter. 77 over 60. So this is 77 pi over 60. $125 times pi over 180. $125 divided by 180. Math, enter, is 25 over 36. And we leave pi in our answer. $330 times pi over 180. We do 330 divided by 180. Math, enter. We get 11 over 6. Be 11 pi over 6. Next one, 240. Go back to our calculator. 240 divided by 180. Math, enter. And we get 4/3. So this would be 4 pi over 3. Last one for practice, 931 times pi over 180. We have to put in the calculator 931 divided by 180. Math, enter. We get 931 over 180 because it doesn't reduce any. So this will be 931 pi over 180. So that's how we convert from radians to degrees and degrees to radians. Need to mention coterminal angles and how to draw them. Angles are coterminal angles if they have the same initial and terminal sides. Same initial and terminal sides. So in order to have the same initial and terminal sides, they would have to go around the circle one more time or not. Go the other way, negative, go positive, a multiple number of times to be in that same spot. So here's how you find coterminal angles. With degrees, to find coterminal angles, we can add or subtract 360. With radians, we add or subtract 2 pi. So let's do a couple. 3 pi over 4. Most students can't picture on a circle what 3 pi over 4 radians looks like. So I tell them, go ahead and convert it to degrees. So if I do 3 pi over 4 and I want it in degrees, I'll multiply by 180 over pi so that the pi's will cancel. And I can now multiply 3/4 times 180. So 3 times 180, enter, divided by 4, and I get 135 degrees. So I want to draw an angle that's 135 degrees. Okay. There's my initial side. I know that this is 0, this is 90, halfway around the circle is 180. So that 135 needs to be somewhere between this 90 and 180. If I add another 45 degrees to 90, that's going to put me halfway. So that's what it looks like when I draw it. Now I need to sketch one positive and one negative coterminal angle, or figure out what those are. Well, if I'm at 3 pi over 4, I'm going to add 2 pi to get the positive angle. Well, 2 pi is 8 pi over 4, so that would be 11 pi over 4. And I'm going to subtract 2 pi. So 3 pi over 4 minus 8 pi over 4, that's going to give me a negative 5 pi over 4. Those would be a positive coterminal angle and a negative coterminal angle. Okay. Number 2, 7 pi over 2. If I want to convert that to degrees, I'm going to do 7 times 180 divided by 2. 7 times 180 divided by 2 gives me 630 degrees. 630 degrees. Well, this is one revolution, that's 360. If I go one more time, that's going to put me at 720. Okay, I need, what is it, 630? So I need to be 90 degrees less. So I'm going to go to here. Okay. So if I look at it, that's 3.5 pi. So that's 2 pi, 1 pi, and a half pi. So I'm in the right spot. Now all I have to do is add and subtract 2 pi. So if I add 2 pi, I'm going to add 4 pi over 2. It's going to give me 11 pi over 2. And if I subtract 2 pi, that's going to give me 3 pi over 2. So just to show you that it works, if I draw 3 pi over 2 as an angle, and I start here, 3 pi over 2, that's 1.5 pi. So 1.5, my line's going to be here, which is the same as 7 pi over 2. Complementary and supplementary angles. You've heard of this, I think, probably starting in elementary school. Complementary angles are two angles whose sum is 90 degrees or pi over 2 radians. Supplementary angles are two angles who add up to 180 or pi radians. So in this example, we want to find the complement of 2 pi over 5. Well, if we subtract that from pi over 2, we'll get the answer pi over 10. So the complement of 2 pi over 5 is pi over 10. If you add those two angles together, you get pi over 2. Notice we had to convert the fractions. If I want to subtract 2 pi over 5 from pi over 2, I need a common denominator. So I multiply the denominators. 2 times 5 is 10. How many times will 2 go into 10? 5 times. 5 times pi is 5 pi. How many times will 5 go into 10? 2 times. 2 times 2 pi is 4 pi. The supplement, I want to subtract 2 pi over 5 from pi. Well, if I do that, and I make 1 pi, and I put it in terms of a denominator of 5, and I subtract 2 pi over 5, 5 minus 2 is 3. So I get 3 pi over 5. Arc length. Arc length is a formula that we'll use to find out the partial length around a circle. So arc length has an S in it, which stands for arc length. We also have R, which is radius. And we have the Greek letter theta, which in pre-calculus, we use Greek letters as angle measures because we don't want to use X, we don't want to use Y, we see that too much in math. So pi is the angle measure in radians. So here's our formula. To find the arc length, you multiply the radius times the angle measure, and the angle measure must be in radians, not degrees. So we're going to find the angle in radians if R is 10 and the arc length is 120. R is 10, the arc length is 120. So what do we have to do to solve for theta? We divide by 10. Okay. And we get 12. You can also use this form of it. Theta equals S divided by R. Find the arc length if the radius is 10 and the angle measure is 20 radians. We're given R and we're given theta. Multiply those two numbers together, we get an arc length of 200. And that's how we use arc length formula. Okay? So if you got any questions, stay on the Zoom video and I'll help you with any of those. Otherwise, have a good day.